Hello learners, welcome back to Introduction to Statistical Thinking. Today we are going to be talking about branches of statistics, and the lesson outline for today will be we are going to be exploring the different branches of statistics, and I'm going to explain descriptive statistics to you. We explain some measure of central tendency, we explain some measure of spread, and also measure of partition. And I'm going to do some introduction to number summary and explain box plots. There are two major areas of statistics that are well known to us. That is descriptive statistics, which describes the properties of sample and population data. And the second one is the inference statistics, which uses those properties to test hypotheses and draw conclusions. Some common statistical tools and procedures for descriptive statistics are usually categorized into two. One, measure of central tendency and measure of spread, then measure of partition. So what is measure of central tendency? The most common measure of central tendency are the mean, the median, and the mode. And this measure of central tendency are usually known as measure of location or average. Mean, this is simply an arithmetic mean which signifies the sum of L elements that divided by the number of elements, and the mean is usually denoted by bar for a sample mean, while the population mean is denoted by the symbol μ. So the median is the middle value where the data is arranged in ascending or descending order. So what is mode? This is the value that occurs most frequently in the data set. It appears more often than any other value. So you can easily get the mode by tabulating your data set. You put it in tabular form. So now measure of spread. This is also known as measure of dispersion and is used to describe the variability in the data. It tells us how wide the data set is from each other. So the common measure of spreads are the range, standard deviation, and variance. So what is measure of spread? The range. Range is the difference between the highest and the lowest value in a data set. It is simplest measure of spread, while variance measures how far each of the value in the data set is from the mean value. A small variance indicates that the data points tend to be very close to the mean and to each other, while a high variance indicates that the data points are very spread out from the mean and also from each other. So the sample variance is usually denoted by S squared, while the population is denoted by rho squared. So standard deviation is the square root of variance. That is the relationship. And we represent this standard deviation by S. Measure of partition are measures that divide a distribution into a specified number of parts. So these are the common measure of partition, the quartiles, the percentile. So what is the quartile? This quartile measures the device frequency distribution into 4 equal parts. That is, we have the Q1, the Q2, the Q3, the Q4, where the Q1 stands for the first or the lowest quartile, Q2 stands for the second quartile, the Q3 stands for the third or the upper quartile, while Q4 stands for the fourth quartile. So the second measure of partition is percentiles, and it divides the frequency distribution into 100 equal parts. P1 stands for the first percentile, P2 for the second percentile, until we get to P100, which is the 100th percentile. So what is number summary? The 5 number summary in statistics, they are a set of descriptive statistics that provides information about a data set. So they consist of the minimum value, which is the smallest observation, the lowest quartile, which is the first quartile, the median, which is usually the middle value, the upper quartile or the third quartile, and lastly, the maximum, which is the largest observational value. So what is box plot? Box plot is a chart that can be used to show or represent the 5 number summary. So this is the figure that represents the box plot, where you have the minimum value here to be at this tail, then the first quartile, which is Q1, is here. The Q2 is usually the median or the middle value, and the third quartile is Q3, and you have the maximum at the upper tail. So the differences between Q1 and Q3 is what we call an interquartile range. So this is the vertical representation of the box plot. They represent the same thing as this other diagram, where you have the smallest whisker to represent the minimum. We have this is the lower quartile for Q1 and Q3 for the upper quartile. The median value is usually in the middle between the Q1 and Q3, and the upper whisker represents the maximum value. We now move on to our Jupyter Notebook to show us how the statistical thinking operates and some of the codes that we use. Come along with me. So this is statistical thinking 1. So I'm going to show you how we do this. Remember that when we want to start running our code, we first import packages that will be useful for us while we are working. So you import packages like NumPy as NP, you import Pandas as PD, you import matplotlib.pyplot as PLT, and Seaborn as SNS. So I run it and see the result. And like I said earlier, when you see the star sign, shows that it is still running, and when you see the figure, that means that it has run successfully. There is no error. So the measure of central tendency that I explained earlier, that mean is one of the measure of central tendency, and it means the sum of all of the elements divided by the number of elements. So you add up all of the elements in the data set and divide by the number of elements for sample mean, and you also do the same for population mean. So this is an example. Supposing that we want to add ages of 10 students for CSE2. So if these are their ages and they vary, we have 14, 25, 17 up to 13. So to calculate the mean now, we add up all of the numbers. Since the numbers are 10, we divide by 10 and our result is 18.1. So that is the mean age. But if you are going to run it using our Python notebook, you use the keyword np.mean. We had already taught this in the Python class. So that's why you import your NumPy as NP, then these are the values, you turn them into an array of NumPy, then you can now find the mean age. Let us run and see what result it gives us. You can see that we have the same result here, 18.1, as what we have here as our result. Or alternatively, if you have your data set here, you can also use age.mean. Let's try it. It gives us the same value. So another example is of a professor of computer science whose name is Adisu. He works at Addis Ababa University, Ethiopia. So on a weekly basis, he used to give money to Ethiopian birr to best students in weekly assignment. So these are the bonus that he used to give, the money that he used to give all of the students respectively. So we want to find or calculate the mean of the tips that the bonus that I used to give students on a weekly basis. So you turn the money into an array, a NumPy array, and try to find the mean value. So we name the array money. So if you run it, we will get 501 and 2 as the Ethiopian birr. That's the minimum, that's the average value of the money that Professor Adisu give to his students on a weekly basis. So now we move on to median. We had already explained what median means, that when your data set is arranged in either ascending or descending order, then you try to find the middle value. So an example is we have 13 students that registered for programming with Python CSE2, and their performances of the students are shown below here. These are their performances. We could see that the numbers are not sorted, and we say that we need to arrange it either in an ascending order, that is from the smallest to the highest, or in a descending order, which is from the highest to the lowest. So we see that the values they are arranged here, and usually when the number of your data set, when they are odd numbers like 1 or 3 or 5 or 7, we usually pick the middle number as our mean. Or if you have an even number in your data set, then the two middle numbers, you add them together and find the average. That's what we use as mean here. So after having arranged our value, now let us use our Python to calculate the median value. So we call this our array. This is our array. We call it performance. So now we want to find the median for this performance. So our median value is 12, which is exactly what we got here, where we calculated it without using our NumPy notebook. And we also note that the NumPy object has no attribute.median, so we can never use performance.median here. So you can't try to use performance.median just like we had used in the main up there. So another example is still we have 16 students that registered for introduction to computer science, and these are their scores and their performances. So you will notice that this is even number. The number of students is even number. So what we do is that the first thing is that we arrange this number in either ascending or descending order. Then the two middle numbers, which is 8 and 9, we add them together and find the average. So if you have 13 plus 15 divided by 2, it gives you 14. So let us verify our result using Python, whether we get the same result. We got 14.0, which is also the same as this. So now when we move on to mode, remember that we define mode as the value that occurs most frequently or that we see often in a data set. So an example is Mr. Jamal, that is a native of Somalia, and he recorded the number of phone calls he received during the month of December 2020. So the amount of calls he received for each day were as follows. So these are the number of calls that he received. So we want to find the number of calls he received most in December. We could put it in a tabular form. 0 means no calls, while 1 means one call means that if you receive one call 6 times, so these are the number of frequencies, the number of times that he has received the call. So therefore, the calls with the highest number of frequency appears in the mode, which is 8. So he received 2 calls in a day for 8 times. So in this case, 2 is our mode. So how do we calculate this using the Python? So the first thing we do is that we import the SciPy module or package, that we import stat, that will allow us to calculate the mode for. So we use start.mode function to calculate the mode. So let us okay, let me import it and then we run it and compare our value. So we see that the mode is 2 and the array is 8. So 2 appear 8 times. So another example is according to the United Nations that there are 54 countries in Africa, and each country in Africa is grouped into regions. So we have regions like Central Africa, like East Africa, North, Southern and West Africa. So these are the number of countries that we have in each of the region. So now what will be the solution? Because we want to calculate which region has the highest number of countries. That is, we resort to the mode. So the table above, we can see that East Africa has the highest number of countries because it has 18 countries in total. So now our class activity will be that you resolve this by trying out the responses of farm workers hired during a typical harvest season in Tigya. So their responses were this. So you try to find the mean, the median, and the mode of the farm workers hired using Python code. So the next topic will be measure of spread. So this measure of spread, like we have said earlier, is also called measure of dispersion and usually used to describe the variability of our data. So the component spreads are the range, the standard deviation, and variance. And don't forget that we had already defined our range to be the differences between the largest value, that is the highest value, and the minimum value. And we have an example here for the range where you have all of these values here. So we want to calculate the range in the data set. So the logical thing to do using the range function is to find the maximum value and the minimum value and make subtractions. So we have the maximum value to be 25 and the minimum value to be 11, and our range is 14. So now the variance, how do you calculate the variance, or what is the variance? We had discussed that earlier. That is the average of the square differences from the mean. So this is the formula representing the variance, where this summation sign means sum of, then this mu means population mean, X bar means sample mean, then N means sample size, while capital N means population size. So an example are these three different beautiful giraffes. We have them in different heights. So, and the height of the giraffes in South Sudan Zoo, they are shown. These are the size of the, and one has 133 millimeter, 146.5 millimeter, up to 55 millimeter. So we want to find the variance of the height of the giraffe. How varied are they from each other? Usually our solution will be x is the height of the giraffe, so we find the mean to be 106.3 and the sample variance will be 1290.1. So therefore the variance of the height of the giraffe is this. So let us see how we can do that using our Python code. So with our NumPy.variance, we can get the variance of an array. So this is the array. So we want to get the variance. So if we click run, we have 1075.1. We'll see that this value is different from this. So, and the reason is because this our np.var can only calculate population variance, couldn't really calculate the sample variance, which is what we need exactly. So, however, we see that it does not have the same units of height. So, therefore, we introduce the concept of standard deviation. But one problem with this variance as a measure of dispersion is that it does not have the same unit of measure as the original data. So, and the example is data containing height measured in millimeter as a variance measured in squared millimeter. So, then the next topic is standard deviation. That is the root of the variance, and this is population variance, and this is the standard deviation is the square root of variance. So the example is the value we got 1290.1. We find the square root, so our standard deviation is 35.92. So how do we calculate this using our Python notebook? So from our Python notebook now, we employ the use of this package numpy.std. So this one will instantiate the standard deviation mode, and you have all of the heights here. You can find the standard deviation of the height here, and don't forget the variation in the value that we got. This one is 32.79, where we got at 35.92 here. We said that the variance for this value does not usually usually use population variance instead of sample variance. So lastly, we'll talk about a measure of partition, that they are measures that divide your distribution into specified number of parts. And we had discussed earlier what a quartile is and what a percentile is, and these are the formula to calculate the item, and also for the interquartile range that is different between Q1 and Q3. So I'm going to show you an example, like that you should compute the first quarter and the third quarter, and also the interquartile range for the data relating to marks of 13 students in the introduction to statistical thinking. And these are their values ranging from 10 to 17. So now, how do you find the interquartile range? That is the Q1, the Q3. So the solution is thus: you have 13 number of samples, and we have arranged the value in ascending order. That means from the smallest to the biggest. So, And remember that our Q1 is n plus 1 divided by fourth position. So now the first interquartile is n plus 14 divided by 3. So 12 is our Q1, and you use this formula to calculate Q3, and for the Q3 we have it at the 10.5 fifth position. For the third quartile range, it will be within the 10th and the 11th position. The 10th and the 11th position, so that means that the value should be around here, while for Q3 it should be around 10.5 between this and this value. So if you want to find the interquartile range, we said that the interquartile range is Q3 minus Q1, and our Q3 is 16.5 while Q1 is 12. So our interquartile range is 4.5. So the quarter divided into 4 parts using 25%. So the first quarter Q1 is 25%. This is the 25th percentile, while you have the 50th percentile to be in the middle and is also represent the median, and the third percentile represents the third quartile. So that is how it is. Our data is divided into quartiles and percentiles. So how do we now calculate this using our Python? So we are going to do that with the help of the quartile package. We will import it, where we represent A as the array and Q as the sequence of quartile to compute. So the sequence could be 0.25 for the 25%, Q2 for 50%, Q3 for the 75%. So let us do that for the problem above. So the marks of the 13 students are this, and we want to A to stand for each of the marks, and we want to calculate for quartiles for the 25th quartile, which is the first quartile, and the 75th. So if you run this, so it gives you 12 and 16, which is also the same as the answer we got. So if you want for the interquartile range, it gives you 16 minus 4, which is what we got earlier. So now for the percentiles, this measure frequencies distribution into 100 equal parts. So just like we have explained earlier, the first one, P1, gives you the first quartile, while P100 gives you the 100th quartile, so percentile. So this percentile indicates the percentage of scores that falls below a particular value. So they usually tell you how this score stands relative to other scores. So an example is this. You have a range of people from male to male, and then they have them in different heights, and for high jump training in Kenya, so 80% are shorter than you. So that is dividing the number of trainees into parts, into quartiles. So the 80th percentile are taller than you. So, and we can also represent that using our distribution diagram, where you have Q1 to represent the 25th percentile. That is the relationship between them. So how do we use our Python to calculate the percentile? Just like we did for the quartile, you could also use the NumPy, the percentile, you import the package. So for the two quotient, A is your array, don't forget, and Q is the sequence of the percentiles to compute. So for the quartile, we use Q as 0.25, but for percentile, we use 25 because we are dealing with percentage value here. No? So an example that we talk about of trick here is Mr. Fwenki, a Tigrayan, has a hen that laid 10 eggs. So each egg has weight and recorded in grams as follows. So one is 59 grams, the other one is 56, up to 51 grams. So we want to calculate the 75th percentile, of the weight of the egg using Python. So what we'll do is that we will name our array egg and put them in a NumPy array and try to calculate the 75th percentile here. So let us run and see. We see that the 75th percentile gives us 60.5. This means that 75% of the egg are lower than 60.5. So a larger percentage of the number of eggs have their weight to be lower than 60.5. So the last but not the least, I will introduce you to the introduction to number summary, where we talked about the minimum, the lower quartile or the first quartile, the median, the upper quartile, and the maximum quartile using the box plot. So for the box plot now, it represents the 5 number summary, where you have the maximum here. I showed you that earlier, and you have the minimum here. You have the middle value to be Q2, and this is the interquartile range for the vertical position of box plot. Or you could also have an horizontal position for the box plot. They represent the same thing, and you can always get the same result from them. So an example that we are going to talk about is still our egg problem that we created earlier, and we now try to draw a box plot of egg, and we title it a box and whisker plot for the eggs. So let us try to run this. Wow, so we can see the box plot for the egg laying problem, and we could see the highest whisker here indicating the highest number, and then we also have the lower whiskers here, and the middle value here, the middle value is here, and we could also always trace it back to our y-axis so that we get the exact value of what we are looking for. So now we are going to try and answer this question as our classwork. So, and I'm going to guide you on how to do that. So, the problem is the life expectancy of problem living in one of the 54 countries in Africa in the year 2020, and the data set is named African life expectancy. So you can also get the problem from this link. So the first task is you import the data set. Note that the data set is already in the dataset library. Then we calculate the life expectancy of your own country or any country of your choice. Then the third task is to find the number summary of life expectancy at birth and the interquartile range of the data set. Then you should also draw a box and whisker plot. So the solution, what is the first thing to do? The first thing to do is you import all of your various packages as our tradition, because you import NumPy as NP, you import Pandas as PD, you import Seaborn as SNS, so that we can use that to draw our graph. So with that, you run it to successfully import all of your packages. So now we have run it and there is no error. So the next thing to do is to read in your data set. You import your data set, or you call your data set which we will work with. And don't forget that the title of our data set is African Life Expectancy, and it is in a .csv file. So, and we also name it life expectancy. So we have successfully import the data set. Then it is a good practice to always check the data set you upload, whether it is uploaded correctly or it is the exact data set that you want. And we can always do that with the keyword head. You instantiate it so that it shows you just a few samples of the data set. And we see that in the data set, we have the country, the life expectancy at birth, and we also have the year. So which is what we want exactly. Now, the solution 2 is that for the second task, what is the life expectancy of your own country? So assuming that you are from Ethiopia, then you can run the life expectancy for your country, Ethiopia, by writing Ethiopia here. So if you run it, you see that the life expectancy for Ethiopia is 68, and it is at row 12. Okay, now imagine if I'm from Libya. Another student could be from Libya. So if we type Libya here, let us run and see what it gives us. Wow, it gives us the life expectancy for Libya to be 77 in the year 2020. Assume another student coming from Tunisia. Let us see what we have. Yes, you could see that Tunisia is on the third row and the life expectancy is 76 and in the year 2020. So we could run that for all of the students in the class. So the third task is that you should find the 5-number summary of life expectancy at birth and their interquartile rate. So how do you do that? So you could do this using the describe function, which gives you the descriptive statistics. So with the descriptive statistics now, it shows that we have 54 countries here according to the count. Then the mean is 64. The standard deviation is this. This is the minimum value up to the maximum value. So, but the 5-number summaries are the minimum. So you can usually get the minimum from it. The minimum value is 53, while the first quartile is 61, that is the 25%. The median, which is the 50% in the middle, you have 50% here. Then the third quartile, which is 75%, you have it as 67. Then the maximum value, you have it as 78 for life expectancy at birth for many countries in Africa. So the last but not the least is that we want to use the box plot to check for the interquartile range and the first quarter, the second quarter, and the upper quarter. So we do that by employing this box plot keyword to draw for the life expectancy data. So this is our box plot. So from our box plot now, we could see the minimum whisker here and the maximum whisker here, and this is our middle value representing this line here. Then we have a bit of anomaly here, an outlier. We call them outlier. That these are usually high value that does not fall within this range. So I hope you have enjoyed this video. Thank you. See you in the next class. Bye.